Hello, in this video, I'd like to talk about how to use linear regression to solve regression problems and using Desmos particularly. So in this particular problem, we have the X values representing years and Y values representing average monthly cost to workers for family health insurance. So here, the year 2009 is represented by the value 0, and the year 2010 is represented by value 1. So the year 2014, which is evidently 5 years after the year 2009, is going to be represented by 5. So you want to open up desmos.com over here. And I recommend having an account. So that way, when you start graphing, you can actually save your document. So you just have to click save here and type, let's say, linear regression. And so that way you can have access to this file. As you can see, I have a whole bunch of graphs that I have access to that I can open up anytime. So what we want to do, first of all, is plot the table of values here that we're given. So I'm just going to enter them in. So the plot should appear on the right now. We don't see it at the moment because, as you can see, the Y values are quite large, whereas the table, the graph we're looking at, the range varies for small values. So what we want to do is adjust the range here. Go to the top right corner here and change the Y values to something like 250 to, let's say, 410. So those are the smallest and largest values that we have. So I'm just going to adjust it that way so we can see the table. Now, what we're looking for is a line which passes through these points as best as possible. Now, as you can see, these points are not collinear, but we can find a line which fits through them as best as it can. So the way we're going to do that is we're just going to enter here the following code: Y1 and then the tilde symbol, which is in the top left corner of your keyboard, and then mx1 plus b. So the x1, y1, as you can see, appears right here. So whatever you call these, you would have to call these the same way. Now, m is the slope and b is the y-intercept. So you're welcome to use different letters instead of m and b, but the tilde is important, as well as the x1 and y1 should correspond to what you have here. Now, what you're looking at is the analysis completed by Desmos. You can see the slope here is 20.0286 and the y-intercept is 301.095. Another value you want to look for is R. R is the correlation coefficient. It is a measure of how well the line actually fits through the scatter plot, which is what we're looking at here. And you want this value to be close to 1, or rather, you want the absolute value of this number here to be close to 1. So now when R is positive, it means that we have an increasing line, and when it's negative, we have a decreasing line. You want this number to be close to 1. The closer it is to 1, the better is the fit of this line along the scatter plot. So in this case, we have 0.985, which indicates that the line indeed fits very well when it comes to these points. So over here, to answer the first question, we just need to enter the slope, which was 20.02. Actually, it's 03 because we need to round to the nearest hundredth. And then 301.1 would be better. Okay, so that should do it. And the next question is, we have to make sure that we have to predict the average monthly cost for the year 2021. So basically, we need to enter the X value here, and that will give us the Y value. Now, the year 2021 is about, what is that, 12 years after, right? The year 2009. So that means we're just going to enter 12 in for the X. Okay, so just to be sure, let's so 2021 is 12 years after 2021, right? So you can see the year 2010 is 1 year after 2009, so that corresponds to 1. So in this case, it corresponds to 12. So what we're going to do is enter 12. We're going to plug in 12 for X into this equation here, right? So what that means is I'm just going to multiply 12 by 20.03 and then add 301.1. I'm just going to do that right now. Sorry. All right. So we're just going to type 20.03 times 12 plus 301.1. So this should be the correct value. So I'm just going to copy and paste that here. All right, the next question is asking us to simply compare this value with the value that was obtained by simply collecting data, right? So this value over here was obtained by collecting data, real life data, whereas this value over here is obtained by, mathematical prediction, which is what we did. So the problem is basically asking us to compare the two values. Okay. So to do that, I'm just going to subtract them here. So it's minus 500.63. So 40.83 is the difference. So this value is more than 40.83, it looks like, right? And then the next question is, what is the correlation coefficient? That value you can find over here, 0.985, rounded to the nearest thousands. And finally, it's asking us whether that indicates that we have a strong correlation. In other words, the line actually does fit through those points well. And the answer is yes, because the line fits because the correlation coefficient is close to 1. And that that about does it. We conducted what is known as a linear regression to be able to predict, or which is called extrapolating or interpolating, right? Predicting what would be the y value when given another x value.